Hey guys, it's Krish with another video on cancer today, and this time we're looking at the behavior and classification of tumors. Please bear in mind that this is not going to be about the diagnosing and staging of cancer, just about the nomenclature and research aspect of how we name these tumors, okay? This is going to be the last one in our medical series for now, just because we've had a lot of medical lessons. After that, we're going to move on to some non-medical stuff and then come back to medicine in a few weeks, maybe. So let's get started with determinants. There are three that we need to think about when we're naming our tumors and classifying them. The first of these is the differentiation cell type: epithelial, mesenchymal, and mixed. So epithelial cells, for example, skin cells, or mesenchymal cells, for example, muscle cells, are named differently when it comes to tumors, and we're going to talk about the specifics in a second. Occasionally, you do get a mixture of them, and these can be a bit more aggressive as tumors, because basically, if you recall, you've got different signaling pathways going on inside the body. And when you've got a mixed tumor, it means that it's differentiated from one cell type into another. So we call it poorly differentiated because it's very different from its original cell type, and therefore it's very different in function and shape and everything, really. What that means is it's less likely as this new cell to listen to the body's signals telling it to stop growing, and it's more likely to act up and go a little bit crazy, which is why mixed cell type tumors can be a bit worse to have. We also need to think about the embryonic or normal origin of these cells. So the ecto, endo, and mesoderms you'll remember from embryology lectures. For example, skin is ectoderm, stomach is endo, and bone is mesoderm. Obviously, this is not an exhaustive list. These are just three examples of these three different tissue cell types in terms of origin. And that also affects how we name our tumor. And finally, the behavior, whether it's benign or malignant, and we'll talk about the details of that later on. So let's get into the specifics of epithelial and mesenchymal cells and how we're going to name them differently. So epithelial tumors, you use the word carcinoma when it comes to the malignancy, okay? So carcin referring to the cancer and oma referring to the tumor. So the first thing we do, before we even get to that actually, sorry, I'm jumping ahead. So the first thing we do is look at the tissue of origin. For example, squamous epithelium. Then we think about whether it's malignant or benign. And we also think about the morphology, which is the shape and how it looks under a microscope. So let's do the first one then, okay? So squamous epithelium. Now, the benign tumor looks like papillary cells, okay? So we're going to call it squamous cell papilloma. Oma by itself without carcin to show that it's a benign tumor, okay? So this is nothing to worry about as such. After that, if it's malignant, then we have squamous cell, and we forget about the papilloma. We just add carcinoma. Carcin, because now rather than looking like a papillary cell, it now looks like a cancer cell. So carcinoma, okay? And the same kind of pattern repeats for all of the other epithelial cells. And mesenchymal is a little bit different, not much. Basically, the key thing you need to remember is that for mesenchymal, you use sarcoma instead of carcinoma. It's very unlikely that they'll ask you to, name all these tumors. What they may do, however, is give you the name of the tumor and ask you to talk about its properties, which is why you need to remember that sarcoma is mesenchymal and carcinoma is epithelial. And generally speaking, oma by itself refers to a benign tumor, although there are some exceptions that we will go over soon. And by soon, I mean pretty much now, really. So first of all, let's talk about mixed differentiation, ones that I spoke about earlier in terms of them being a bit more aggressive. So these ones, we're going to use the word carcinosarcoma for. So now that we've basically combined the two words, we know that there's mixed differentiation going on here. So carcinosarcoma. Something interesting can happen every now and then called a teratoma, which originates from all three germ layers. So not just the endo, ecto, or mesoderm, but all three, or perhaps all two, not necessarily all three, but either way, multiple. Now, these can be quite freaky to look at, so do take a look if you're interested. You'll find tumors originating from the stomach, for example, but they'll have hair, nails, and teeth. It's strange, is the best word to describe it, I guess. We also need to think about misnomers. Now, these are tumors that are named as if they should be benign, or they're named as if they should be something else, but they're actually something else. So hepatoma, for example. Now, based on everything we just learned about mesenchymal epithelial cell types, we would think that hepatomas are benign because they don't have carcin or sarco. It's just oma. However, hepatomas are actually a malignancy, so cancer, of the liver. At the same time, we do have three others we need to think about. Now, melanoma and lymphoma, you're probably already familiar with, even if you're a non-medic. Melanoma being that skin cancer that tends to spread very quickly, and lymphoma, Hodgkin, non-Hodgkin's, either way, it's a blood cancer generally speaking. The other two, however, you'll get used to in your future studies as a medic. Hepatomas and seminomas. So liver cancer and seminomas refer to a malignancy of the testicles. So these are the four exceptions that we just unfortunately do need to learn. But that shouldn't be too difficult because, like I said, you'll get used to the two outliers and the other two you already are familiar with. Now let's talk about benign and malignant tumors and when to worry and when not to worry. So benign tumors are often localized and confined, so they have a little border around them, a little boundary that prevents the cells inside escaping to other parts of the body, okay? So these are ones that we don't generally worry about. They are slow growing because they have a low mitotic rate, so the cells divide relatively slowly, and they're often well differentiated. Apologies for the typo in the video. Generally speaking, you don't have to worry about benign tumors. Lots of people have lipomas. I've got a few myself. It's nothing to lose sleep over. But every now and then you do get something called compression from these. So I know someone who, for example, had a lipoma in their spine, and normally you wouldn't worry, but because it's in that annoying little place, the tumor was basically compressing nerves in the spine and causing numbness and pain. And that's when you do have to, take some medical action and perhaps get some surgery to remove the tumor. But that's not always very common. On the other hand, malignancies, obviously we worry about. These are cancer. They are very fast-growing tumors often because they have a high mitotic rate. The cells are dividing very, very quickly. They've gone beyond the limit called the Hayflick limit, which prevents cells dividing too much. And malignant tumors are able to ignore this and just keep dividing forever and ever, and they do this very fast. Okay, they're often also poorly differentiated. This means, if you recall from what I just said a couple of slides ago, this means that they are different to the original cell type. So, for example, an epithelial cell that is now differentiated into a mesenchymal cell. This means it's more likely to ignore healthy signals from the body and produce its own negative, harmful, malignant signals to keep itself alive and growing. Malignant tumors are often non-encapsulated, which gives them a metastatic potential. Metastasis we'll discuss in a second in depth. But either way, they don't necessarily have a boundary around them that keeps the cells within a little pouch, so they can spread to other parts of the body, which is basically what metastasis means. Obviously, we do worry about cancer, that goes without saying, really. So let's talk about metastasis. It's basically the main defining factor of malignancy. It's characteristic of it. Now, there's quite a few steps, but we've condensed them down into 7 for you guys to remember. So just try and remember these key kind of hot words. Okay, these are very useful in exams, and they do often come up. So the first thing that happens is angiogenesis. Now, going back to the last lesson I had with you guys, you'll remember that angiogenesis is the act of developing, so genesis, creation, creating new blood vessels, angio referring to these blood vessels. Okay, so angiogenesis is the act of the tumor creating new blood vessels, redirecting blood to it. This blood carries nutrients and growth signals to keep the tumor growing, so this is basically sustaining itself. Now, the second thing that happens is called primary detachment. So essentially cells from the original tumor start to detach because remember, it's non-encapsulated. Now, these cells start looking to escape. Over time, this takes you to the third step, basement membrane degradation. So you may remember from histology lectures, if you've had them yet, that you've got different cell types separated by different membranes. So the basement membrane separates basically often the epithelium cells from everything underneath. So you've got the epithelia, and then you go a bit further down and you've got the basement membrane. If this degrades, it basically breaks that boundary and allows the cells above or below to migrate into the opposite area. So that's what happens with the cancer. Now, with this, you get something called intravastation. If the basement membrane has degraded, then the cancerous cells can basically enter blood vessels, intravastation. So they're basically now entering the circulation. They've gone inside your vessels and they can travel around the body. Now, as this blood circulates around the body, these cells can stick to certain vessels and certain parts of the circulatory system. This is called adherence because they're adhering to that part. Over time now, these can undergo something called extravastation. So remember, intravastation is inside the blood circulation and vessels. Extravastation then is outside. So basically, you've got these little tumor cells going around in your blood. They stick to a certain point. Now, once they've stuck to that point, they can leave that point. So they can leave the circulation and enter, let's say, the liver, for example, or any other new organ. So basically, this is how a cancer starting in one area can enter the blood, spread around, and then migrate itself into another organ and start growing there. And this would lead to a secondary malignancy, and that's metastatic cancer. And it's just not the end of the world, but often it's not a great thing to have. It's not necessarily a good sign. We like it when we can catch cancer early enough before it's metastasized, because that makes it easy to treat. We can just cut it out or direct, chemotherapy or radiotherapy towards it. If it's spread to multiple areas now, it's got a higher chance of differentiating poorly, higher chance of becoming a bit scary. So yeah, I mean, that's the end of the lesson, really. I hope you guys found that interesting and helpful. It is a very bleak topic, like I said last time. It is a very high yield one in exams and quite an interesting one overall. So I hope you guys enjoyed this one.